All right, this is Mr. Jern, and I'm going to help you with problems involving conservation of momentum. So we're going to start with an explosion question. And remember, the whole idea behind conservation of momentum is that the momentum at the beginning is equal to the momentum at the end. The momentum never changes, it's conserved. So if we have a 12 kilogram object at rest and explodes into an 8 kilogram object and a 4 kilogram object, the momentum before it explodes is going to be equal to the total momentum after the explosion when you take all the parts together. It says the 8 kilogram object travels east at 40 meters per second. What is the speed and direction of the 4 kilogram object? So what we can do is start with just a little diagram, a little picture to help us visualize this. We have our 12 kilogram object, and it's just sitting there at rest, which means that the velocity is at zero, which means that the momentum is zero. We have one piece that flies off to the east. It's an 8 kilogram piece. And the velocity is 40 meters per second. What is the direction and velocity of the other piece? All right, it's a good question. We probably know the direction, but let's just make sure. Okay, so the way we want to start this is to understand that the momentum initial is equal to the momentum final. The total momentum before the explosion will be equal to the momentum at the end. Initial equals final. And momentum is just mass times velocity. And so what we can do is if we take the mass of the total mass, because it's together, 12 kilograms, times the velocity, the initial velocity, that's going to be our momentum to start with, the initial momentum. And it explodes into two pieces. So what we can do is say, all right, the mass of the 8 kilogram object times the velocity final of the 8 kilogram object plus the mass of the 4 kilogram object times the velocity final of the 4 kilogram object. Okay, so you see what I did there? I just basically set it up so our starting momentum is mass times velocity, the total mass times the initial velocity. It's going to be zero. And then I broke it up, not I broke it up, but I set that equal to, at the end, it is broken up into two pieces. It's got its 8 kilogram object with the 8 kilogram object's final velocity, which we know. And we've got our 4 kilogram mass and that object's velocity, which we don't know. So I can start plugging in my numbers here. The mass total to begin with is 12 kilograms times its velocity, which is 0 meters per second. Okay, we knew where that was going, is equal to, well, 8 kilograms for the mass times the velocity. It's to the east, and so because it's to the east, I'm going to make sure that is a positive number. Okay, we could just kind of do that by default. If we get a negative number for our final answer, we know it's in the opposite direction. What is that? 40 positive meters per second plus the mass of the 4 kilogram object. So 4 kilograms times the velocity final of the 4 kilogram object, which we don't know. So as you can see, we have stuff we can solve for. All of this, anything times 0 is 0. 40 times 8. Okay, now I don't trust myself with math. And so I'm going to turn on my calculator. And let's just double check that here. So 8 times 40, 320. So 0 is equal to 320 kilogram meters per second, and that's the unit of momentum, plus 4 kilogram. We don't know this yet. So velocity final of the 4 kilogram object. Okay, so let's we got to solve for this velocity, so we got to get it by itself. Right now it's being multiplied by the 4 kilograms, so we'll have to divide eventually. But first, before we divide, we have to subtract 320 kilogram meters per second from both sides. 20 kilogram meter per second. And so I get negative 320 meter per second. Forgot the kilogram there. I'll just kind of tack that on there. Is equal to, so this got canceled out by that. This is our 4 meter per second. Wow, I'm doing great here. Let's fix that here. You know what? I'm going to fix this right here too. Let's be consistent, shall we? So this is kilogram meter per second. So 4 kilograms times velocity of the 4 kilogram object. Okay, so now we get to divide both sides by 4 because we had to solve for v. So I'm going to divide by 4 kilograms. That will cancel that out over there. And whatever I do to one side, I have to do to the other. So divide by 4 kilograms. And what's going to happen here is the kilograms are going to cancel out. And if I take that negative 320 divided by 4, I get negative 80. So let's see, negative 80. And we're left with, that's a meters per second, is equal to the velocity final of our 4 kilogram object. Okay, now negative 80, it's not asking for negatives, it's asking for what is the speed and direction. Nobody goes negative speed, that's not really how you say it. So what does the negative mean? Well, since positive 40 meters per second was our to the east, that means negative has to be to the west. So our answer is the final velocity of the 4 kilogram object is 80 meters per second to the west. Okay, I'm going to put a box around that. That's my final answer. And so just to complete the picture over here, that goes flying because it's smaller. That is what, 4 kilograms? And so that is heading negative 80 meters per second, or 80 meters per second to the west. And it kind of makes sense too, or rather it does make sense because this has half the mass, and so it has twice the speed as the 8 kilogram one. So just kind of keep that in mind, like a little check to see that, yeah, it does make sense. All right, well, I hope that helps.